7.1 is our next section. It's called the area of a region between two curves. So let's think back to the very beginning of our calc class. And remember when we created some sort of a function like this, and we tried to talk about what the area was underneath the curve. So something along the lines, we would do something like this, and then one of the methods we used was, the approximation, drawing the rectangles above and under, overestimating versus underestimating. Okay, but then we learned with integration that if we integrate, if that function is f of x, if we integrate f of x from whatever, this one looks like it goes from 0, and let's just give it we'll call it a. If we integrate from 0 to a, we would get the area under the curve. Exactly. No estimation there. All right, so now we're talking about what happens when we have two curves. This is very intuitive because if this concept makes sense, then this concept, the area between two curves, should make sense as well. All right, so let's just say we had some function. We'll call it, looks something like this. We'll call it f of x. We have another function. We're going to call it g, something like this. And this will be our g of x. So we have two functions. And we want to know what is the area, I'll shade it in yellow, how about that? What is the area between the two curves? All right, so let's think about this intuitively first. Oh, and we're going to say between 2 points. Let's pick point, I'll pick point A here and point B here. I guess I shouldn't have shaded that much then, if that's how much my, I'm only looking for the area between A and B. So let me just shade only between A and B. So we'll say A goes to here. And we'll say B is that intersection right there. So we want to know the area between those two. All right, so let's think about this just logically speaking. If I was looking for the area, looking just at f, if I was just looking for the area under the curve between A and B of f, we would say integrate from A to B f, right? Makes sense based on what we learned at the beginning of the year. What if I wanted the area that was under G? So keep in mind the area under G is this area right here, right? So if I wanted the area under G, that would be the integral, let me switch back to black, from A to B of G. All right, so we know the area under F goes all the way down to the x-axis there. So if I took the area of F and subtracted the area under G, that would leave me with the yellow area, the area between the two curves. So essentially what we're doing is we're subtracting these two integrals to find the area between them. All right, so let's look at an example. Let's say we have, let's do the function f of x. Okay, come on. F of x will be 2 minus x squared. And then we also have a g of x. And we're going to let g of x be just x. Okay, let's kind of look at this graphically. So this is an upside down parabola. And it's going to go up 2. And I'll put it up to 1, 2. It's going to go up to this point right here. And it goes down. And it actually, so it opens down because of the negative. And the positive 2 here lifts it up to vertically shifts it. Sorry, I couldn't think of the word. Vertically shifts it up. All right, so then if we were looking at where it crossed the x-axis, it crosses at plus and minus square roots of 2. So let's say we had 1 and 2, 1 and 2. So it's going to be somewhere in between those two. I'm not looking for anything exact here. All right, so there is my f of x. Okay, g of x, we'll do in red, is y is equal to x essentially. 1, 1. So it's going to go like this. Like that. All right, so if we want to know the area that lies between the two intersecting graphs, so we're looking for the area that's between them. So we know from above we're going to take the area of the upper one, which would be f, subtract the area of the lower one. However, a and b we do not know. So if we were in class, I would ask you, how could I figure out what these 2 points were? Hopefully you would say, well, let's set them equal to each other. So 2 minus x squared equals x. Let's solve this guy. That's x squared plus x minus 2 equals 0. So that would give me x plus 2 and x minus 1 equals 0. So x would be negative 2 and positive 1, which, you know, for my graph, it's not real precise. That looks like that could definitely be negative 2 over here. That looks like, you know, it's a little off, but that would be somewhere in the range of x equals 1. All right, so that would be where my x, that would be my a and my b. Remember, the lower one should always be the lower number, and the upper one should always be the upper number. So if we were to find the integral from negative 2 to 1 of f of x would be 2 minus x squared. G of x is x, so minus x, and then d of x. So this guy is really easy to integrate. We know how to do that. So let's integrate him. Pause the video, do it yourself. I'll keep going. This gives me 2x minus x cubed divided by 3 minus x squared over 2 from negative 2 to 1. All right, so plugging in, we should get, if we plug in 1, we're going to get 2 minus 1/3 minus half. And if we plug in negative 2, we're going to get negative 4 plus 8/3 minus 4 over 2. All right, so, and from here, pause the video and do the fractions if you want. I came up with 7/6 and negative 20 over 6. So when you subtract the 2, we get 27 over 6, which reduces to 9/2. So the area between the two curves would be 9/2. All right, let's try another one. Let's let g of x be cosine of x, and let's let f of x be sine of x. All right, so we want to find the area. Now these are repeating, so we have to have a specific area here. So remember that sine starts down at 0, goes up at pi over 2, intersects at pi, goes down at 3 pi over 2, comes back around at 2 pi. All right, so if I'm graphing, we're going to do sine in blue. So it goes up. Oh, I didn't put that would be a 1, or amplitude there. Okay. Wow, that's not very straight, but that's okay. Amplitude is 1. Negative 1. All right, so then let's do cosine in G. So remember, cosine starts at 1. has the same. Remember, you could find all these on the unit circle if you can't remember them. See if I can make that one any straighter. Not really much straighter. That's okay. All right, so that one's our cosine. All right, so if we want to find the area that is bound between the two functions, then let's look at this area here. That should really look a lot nicer than it really does. All right, so what we're trying to find is where, so the higher one, the upper, is sine, and then the lower function would be cosine. But remember, we have to find where they intersect in order to know where we're integrating between, so our a and our b. So let's say, where is cosine of x equal to the sine of x? So if you remember unit circle, where are sine and cosine equal? So at all the pi over 4s, that x is equal to pi over 4. They're both squared to 2 over 2. And then 5 pi over 4 is going to be where they're equal again. All right, so what that means is we're looking on the integral between pi. The lower bound is pi over 4. The upper bound is 5 pi over 4. And we're going to say from the upper one is sine minus the cosine. All right, so we are going to integrate these two functions. Pause the video, try and do it on your own. Otherwise, I'm going to do it. All right, if I integrate sine, I get negative cosine of x. And I integrate cosine, I get sine. But there's already a minus there. So minus sine x from pi over 4 to 5 pi over 4. All right, so when I plug them in, I should come up with 2 square roots of 2. Okay, let's look at another example. I paused and made the graph so you didn't have to sit and watch me do that. But I'll give you my functions here. So let's say the blue one is going to be, we're going to call it f of x. That's going to be 3x cubed minus x squared minus 10x. Okay, g of x will be the red one, will be negative x squared plus 2x. All right, so we're looking at the area between the curve. This one's a little different because this is a curve that intersects at more than 2 points. So in this case, we are looking for the area between this section and also the area between this section. So we have 2 different sections that we need to find the area between. So the way we're going to do this is we're going to find the area of them individually and then add them together. Just find the area of this one and then find the area of this one and then add them together. So we got to figure out where these 2 graphs intersect. We have 3 points here we're looking for. This one, and this one to find our A's and our B's. So let's pretend like you don't know what they are. I tried to make them very clear, but let's pretend that we actually need to algebraically find them. So let's set our equations equal to each other and solve. So I'm going to add x squared both sides. Those will cancel out. Subtract 2x, then I'll have 3x cubed minus 12x equal to 0. So solving this, I'm going to factor out a 3x. That will leave me with x squared minus 4 equals 0. So I'm going to have x will be 0, x will be positive and negative 2, which again looks pretty obvious from my graph, but you never know. All right, so then we got to find, all right, so these are our bounds. So the lower one is negative 2, the middle one here is 0, and the upper one is positive 2. So you got to pay attention to which graph which function comes first in your integral. So let's do area 1 first. I called that the left one. Area 1, lower bound would be negative 2, upper bound would be 0. So in the first area section here, which function is higher than the other function. Does that make sense? Hopefully you recognize what I'm asking you. F of x is the upper bound, whereas g of x is that lower bound. So we're going to take f of x, 3x cubed minus x squared minus 10x, and subtract that lower bound. So keep in mind we do need parentheses because we're subtracting the entire function. All right, so we'll do this guy here from -2 to 0. So let's combine like terms first. That leaves us with 3x cubed. And again, our x squares cancel out. And then again, actually it ends up being the same as this guy up here, doesn't it? When we simplify. All right, so now go ahead and integrate this guy. Whoops, if we're gonna integrate, we need to take off the integral. So that will give us 3x to the 4th divided by 4 minus 6x squared from -2 to 0. All right, then we're going to plug in. I'm going to plug in 0 and -2, and I've already done it. Kind of cheated here. So this is what I get for the very first one. So that will give me positive 12. Pause the video and see if you need to go back and work it out. Go for it. So that's the area of the first one. So now we got to find the area of the second one. So first of all, we do know that our bounds change, right? Our lower bound in that case would be 0, and our upper bound would be 2. So we would go from 0 to 2. But then notice, this is what I was referring to earlier. Which function is the upper bound? Notice that the red one is, right? So we're going to take the red one and then subtract the blue one. Take g of x minus f of x. So g of x, in this case, is -x squared plus 2x. Then we're going to subtract the f of x because it's the lower function. Again, notice I did have to have those parentheses there. So pause it and see if you can finish it. I'm going to combine my like terms first. Again, my x squared cancel out. Now I'll have -x cubed and positive 12x dx. So when I integrate this guy, I will get -3/4 x to the 4th plus 6x squared from 0 to 2. Then when I plug in, I will get -12 plus 24, which gives me positive 12. Just so happens to be the very same area. But that was my A2. A1 was 12, A2 was 12. So if we want to add them together to find the area between the curve from -2 to +2, we would say area 1 plus area 2 is going to be 24.